You're about to watch one video that's part of a series of videos covering everything you need to know about eating healthier and living a healthier lifestyle as a whole. The series in total is 5 hours long, covering all you need to know. There's also a workbook version available on my website, bainesnutrition.com, that guides you along this journey. Now, the series does build upon itself, so there might be parts of this video that don't make complete sense. So I encourage you to check out the previous parts, and I'll usually reference what that previous part is. You're also welcome to leave any questions or concerns in the comments section here, or you can email me directly at andy@bainesnutrition.com. Without any further delay, let's get into it. So protein is our source of nitrogen. There's 9 essential amino acids, and you want to think of these amino acids as building blocks. If you think of them as letters of the alphabet, you can take A and D, Y, and you get meat, you get Andy. Of course, a little more complicated than that. I'm made up of many, many different proteins. This way you can take different amino acids to make your hair, your skin, your nails, and so on. So every single day, because of our hair and our skin and our gut cells, we're losing a little bit of nitrogen, right? We're losing a little bit of protein every single day. If you translate the 53 milligrams of nitrogen per kilogram, it's about 23 grams for someone who's about 70 kilograms. So we're losing quite a bit of protein, but at the same time, it's not a lot of protein. Now, if you take that 23 grams and you break it up a little bit and you break into like your hair, skin, nail, and gut cells, you're losing about 3 grams a day. The reason it's higher than that is because some of our gut cells, for example, will use different amino acids for energy, like such as glutamate. So minimum requirements are about 20 to 30 grams, which is about 4 to 5% calories from protein. That's the absolute minimum to function, be alive, and do well. So that's the minimum there. So the importance, or I guess the lack of importance of protein for our physiology, our biology, in hindsight becomes a little bit more obvious because we don't actually have taste receptors for protein. Technically we do. I'm not going to get into technicalities right now, but it's not like the same as like the sugar or like the salt, for example, right? If we like an apple, it's like, wow, this is sweet. If we have egg white, it's bland. If you have pure sort of glutamate, MSG, then yeah, sure, you technically have a receptor for like one of the amino acids. And then there's also components in dark leafy greens that make them taste a little bit better to us. I'm forgetting the names of those, but they're in a different video. Egg whites, protein powder, tofu, it's very bland. Compared to animals such as like cats, for example, they will actually taste protein because it's more important for their physiology and their biology. So when it comes to protein, I'm sure you're aware there's a lot of marketing behind it. Marketing for anything, marketing for my service, you are to a certain extent and you want to be overselling the benefits, right? It's like, oh, this is kind of good for you. You want to be like, no, this is the best product ever. It's gonna grow you a third hand, right? Okay, maybe not to that level, but you're overselling it because you have to. That's how you're gonna make profit. And if your competitor is overselling, then you gotta be overselling too. Just how, unfortunately, how the marketplace works. So protein marketing has been incredibly effective at convincing the general public that protein equals muscle. But we want to talk about, is there any truth to it? Yes, minimum protein requirements are very, very low. But that doesn't mean that getting extra protein may not be helpful. It just means the minimum is low. So the question is there a more optimal protein that we might be striving towards that might help us for this healthy lifestyle, for this weight loss, for this building muscle goal, whatever it may be. So let's talk about that. So the example I like to use is, let's just say we're going to gain 25 pounds of muscle in a year. Now, beginner gains usually cap off at about 17 to 20 pounds. So gaining 25 pounds of muscle in a year is a little unrealistic, but let's just say we're working incredibly hard. We have the genetics for it. We have the testosterone naturally in us. And we're going to do this, right? So let's break down that 25 pounds of muscle. I know it's quite a bit of numbers on here. So to break down that 25 pounds of muscle, well, about 75%, a little bit more than 75%, is just water. 25% is the nucleic acids, the DNA, the RNA, the carbs, the fat, and also the protein. But let's just say all of that 25% is protein. That, if you do the math, 25 pounds times 0.25 to get rid of the water, is about 6.25 pounds. If you take that 6.25 pounds and you convert it to grams, because we're interested in how many grams do we need, and then you divide it by 365 to get grams per day, you're going to see the number right here. It's about 7.7 grams. 7.7 grams a day is how much you need for the unrealistic goal of 25 pounds of muscle, assuming 25% of muscle is protein, which it's not, right? So we don't need a lot of excess protein to build muscle. Minimum requirements are still low, but still, this doesn't directly answer the question of if it's helpful to get more. So let's dive a little deeper. So I'm going to use a little analogy to help explain this. Let's just say we're building houses, right? And we're trying to build as many houses as we can, and each house requires 10 doors. If you have 100 doors, how many houses can you build? Quick math will tell you that you can build 10 houses. It doesn't matter how many windows you have, how many walls you have, how many light bulbs you have. The rest of the supplies don't matter. Once you're out of doors, you can't build any more houses. That's the rate limiting step. The body is similar. Those amino acids are building supplies. So when you're out of those amino acids, your body can't build anymore. It does depend on diet, but methionine and lysine are typically the lowest just because of typical food composition. So extra protein does have a small anabolic effect, as in if you have all the building supplies and a little bit excess of building supplies, you hit the gas pedal a little bit more. You just press it like, oh yeah, let's go a little bit faster. So if you're a young, active professional athlete or wanting to be a professional athlete, or you just compete at a high level, the extra may be helpful for more optimal recovery because you're hitting that gas pedal a little bit faster. But there is a downside to this, and the downside comes from the fact that our cells can only divide so many times. That's known as the Hayflick limit. So essentially, if you're hitting the gas pedal faster, it just means you're causing more growth, which means you're aging yourself faster. So as you know, our cells grow, and then they divide, grow, and then they divide, right? So if you do that very, very fast, you go through life very, very fast. I believe the Hayflick limit for human cells is 50, which is quite a coincidental thing. It's on a nice round number like 50 and not 49. But as you age faster, it just also means more problems earlier in life, right? The extreme example of anabolic effect, as you can see in my beautiful Canva friend right here, is that if you have this anabolic effect from like steroids, for example, you will age quite a bit faster. Nowadays, unfortunately, you have many young men that take steroids. They're in their 20s, but they look like they're in their late 30s, early 40s. And it's just because you're causing the anabolic growth faster and faster. Protein isn't quite to that level, as in if you eat a lot of protein, there is an upper limit to how much work your body can do, how much physiology your body can do. And unfortunately, when you have that extra protein, the extra is not stored. The nitrogen is stripped off and you pee it out, right, as urea. So this is the metabolic burden to our kidneys and livers, and methionine and cysteine also have a sulfur component, which adds to that burden. This is why protein for energy isn't as efficient as carbohydrates or fat for getting energy metabolism, because you have to strip the nitrogen off before you can convert it to like a glucose or like a ketone, as in to glucose or fat. So because of this, as we get older, less protein becomes more important because we don't want to be burning our livers and kidneys, especially if we've been burning them for the last few decades, right? We want to give them a bit of a break and easier time. Very importantly, all whole foods have protein to them. So you can see here in orange, we have protein. In red, we have fat, and then in this teal color, we have carbohydrates. So the chicken's gonna be pretty high in protein. When it comes to how people classify foods, we often say like, oh yeah, chicken breast, that's protein, pasta, that's a carbohydrate. I actually move away from that as much as possible, just because we wanna recognize that like, oh, potatoes do have mostly carbohydrates, but they also have protein, they also have fat, right? They also cover your bases that way. So for the chicken breast, for example, I consider chicken breast to be a protein-rich food because most of the calories comes from protein. So we can see that again in the orange here, in the red we can see fat, in the teal we can see carbohydrates. So we can see that even strawberries have about, I think it's 8%. Yeah, strawberries have about 8% calories from protein. Brown rice has, I think, 8-9%. White rice probably closer to 7% calories from protein. So you can see all these foods are well above that 4 to 5% minimum, right? Even if you don't eat the like the black beans, eggs, salmon, chicken breast, like these higher protein foods, and you just ate like basically fruits and vegetables, you will still get enough protein. You'll probably hover closer to like 10% calories from protein, which again is more than double of that minimum, right? May not be the most optimal strategy for feeling full and satisfied, but that is one way of doing things. So when it comes to other foods here, for example, when we see like salmon and eggs, because most of the calories from these foods come from fat, I actually, in my mind, classify them as fat-rich foods, right? Because most of the calories come from there, so they're fat-rich foods. Anyways, moving on. Oh yes, protein and weight loss. So I get tons of questions about protein powders. Should I use them? Should I not use them? When should I take it? How much should I take? So first of all, protein powders are a supplement. Generally speaking, for weight loss, we're not trying to supplement calories in, right? We're trying to do the opposite. For weight gain, and it's kind of funny because you'll see protein get advertised and marketed for weight loss and weight gain. Well, you can't have it both ways. It's one or the other. And I would say, generally speaking, it leans to weight gain because it is a purified macronutrients, about 1,700-1,800 calories per pound. Yes, it's more filling than pure sugar, but it's not in the same realm of how full you feel compared to something that has fiber and water to it, like for example, like some black beans that were on like the last slide. So yeah, don't want to be supplementing calories, don't want to be drinking calories. When we drink calories, they're not as filling, right? If you take a bunch of fruit, you blend it into a smoothie, you drink that doesn't fill you up the same as if you take that fruit and you just eat it like that. And the reason for that is quite simple. When we blend things up, when we process things up that way, refine them in a factory, we're breaking food into tiny, tiny, tiny little pieces. When we chew food, we can only break them down to a little bit less than a couple millimeters. And because of that, we don't absorb all those calories. It takes longer for our body to do that digestion work. We want our bodies to do the digestion work, kind of like with the apple. We want to be breaking up our apple ourselves versus just having the apple juice straight. Because when you refine it outside the body, then it's more efficient, which is good for weight gain and not good for weight loss. So always try to eat the whole food instead. That being said, there are cases where protein powders can be quite helpful as a supplement, even if you're not a young professional athlete or wanting to be a professional athlete. So the first one is protein is about here in calorie density. I hope you can see that, my little blue ball jumping around. Which means that, let's just say in the morning, you go to the gym, you work out, don't have time for breakfast, and you make yourself like a protein shake. If having that protein shake means that we're not stopping for a bagel and a donut, it means that we're not having to eat out at work, it means that we're not eating these richer foods, then have that protein shake. Because the protein shake is about here, right? But if it means you're not eating some of the richer foods, then that's a net benefit moving in the right direction. But if you're having that protein shake and it means now you're a little full and satisfied and now you're not eating some of these foods, which are lower in calorie density, then that's a bit of a problem because that's the direction we ultimately want to be moving. So it is a bit of a personal discussion when it comes to that protein piece. But generally speaking, save your money, don't burn in your body with excess protein, eat until you're full and satisfied. And get that protein from Whole Foods. Yeah, eat enough Whole Foods and you will get more than enough protein. That's the protein short story. Hi, it's future/past me again. Well, we still got some protein discussion left regarding some of these higher protein foods that fall in this richer food category. But for now, we're ready to move on to the third macronutrient, fat. We'll answer some similar questions, talk about the different types of fat, what fats we need, and get into some of the pros and cons of different fatty acids. This and more in the next part. I'll see you there.